Hello and welcome back to the Training Toolbox. In this clip, we will be looking at the compound and pressure gauges of the GARM 125 pump and how to interpret the gauge readings to ensure safe and effective practice. There are a variety of pump panels across different types of appliances. However, for the pump operator, the main gauges are the compound and pressure gauges. Both the compound gauge and the pressure gauge are expressed in kilopascals or kPa. And when interpreted correctly, these gauges will assist with firefighter safety and the efficient use of water. Compound gauge. Gauges can measure pressure only, positive pressure, vacuum only, negative pressure, or may be designed to read both pressure and vacuum. A gauge that measures both positive pressure and negative pressure is known as the compound gauge. The compound gauge measures these pressures at the inlet side of the pump and is an indicator of the water supply still available for use. Negative pressures. A negative pressure is shown on the compound gauge when drawing water from a static water supply. For every metre of vertical lift, a reading of -10 kPa will show on the gauge. It's handy to know that the maximum practical lift when drawing water from a static supply is 8 metres. This suggests that the compound gauge will show a maximum negative pressure of -80 kPa. When drawing water using case 4, the compound gauge needle will slowly move from 0 into the minus pressure area depending on how deep you are drawing the water. As the water level drops, the needle reads further into the negative. Once the pump is primed, the pressure reading should remain steady. If the pressure does slowly fall back to 0, this may indicate a leak in your suction hose between the inlet of the pump and the water supply. Positive pressure. A positive pressure is shown on the compound gauge when the pump is connected to a reticulated water supply, such as a hydrant or another pump. If, for example, you are using water from the main supply of a hydrant that has 500 kPa of pressure, the positive side of the compound gauge will also show 500 kPa when all delivery valves are closed on the pump manifold. The same principles apply if you are relay pumping and connected to another appliance. If you are drawing water from the appliance tank, the compound gauge will read close to 0 as it will only show the minimal head pressure from the tank. You may even find that if you are drawing a lot of water from the tank, that the compound gauge may show a negative pressure. When connected to a hydrant, or if relay pumping from another appliance, you should always ensure that the compound gauge reading is reading a positive pressure. Otherwise, you will overrun the supply of water. Pressure gauge. The pressure gauge measures the delivery pressure coming out of the pump, or the delivery side of the pump. This shows the pressure at the delivery manifold, which will differ from the pressure at the branch, nozzle. So you will need to make sure you adjust accordingly. This shows the pressure at the delivery manifold, which will differ from the pressure at the branch or nozzle. So you will need to make sure you adjust accordingly. The difference of pressure between the branch and the pump manifold is due to friction loss in the hose and depends upon the length of the hose, the diameter of the hose, velocity of water or flow through the hose, and the roughness of the inner surface of the hose. A rule of thumb in calculating friction loss for a standard Duraline hose is 20 kPa per 30 metre length of hose. Friction loss also occurs in pumping water up and down slopes. A loss of 10 kPa will occur for every metre of elevation. Likewise, for every metre of pumping below the pump, the result of an increase of 10 kPa is achieved. By understanding these theories, you can adjust the throttle to achieve a safe, adequate working pressure to the branch operator. A safe working pressure for a single branch operator for long durations is 450 kPa. Exceeding this pressure will result in early firefighter fatigue and possible injury. The compound and pressure gauges respond to each other in opposite directions by the movement of the throttle. So if the throttle is increased, the pressure gauge reading increases and the compound gauge reading decreases. If the throttle is decreased, the pressure gauge reading decreases and the compound gauge reading increases. Taking care of the gauges. Gauges are sensitive pieces of equipment. The most common cause of serious damage to a gauge is shock. Shock results from the sudden pressure of opening and closing the valves too quickly and can cause premature failure of gauges. To avoid this, a good pump operator will always open and close the outlet and inlet valves slowly. You have now come to the end of the clip on compound and pressure gauges. This is just one in a series of informative topics in the training toolbox, which I would encourage you to take a look at. If there is anything you're unsure about, you can go back and watch the clip again. Remember, safety first.